is pertaining to the molding and casting of polymers. Blow molding. The first one is the blow molding. Blow molding covers the three main thermoplastic processes: extrusion, blow molding, stretch blow molding, and injection blow molding. Extrusion blow molding is the largest of the three, followed by the stretch blow molding and injection blow molding. The extrusion, how molding is the largest process, user of the high density polyethylene. Blow molding is the forming of a hollow object by inflating or blowing a thermoplastic molten tube called parison in the shape of the mold cavity. The process consists of extruding or dropping a parison on the which female mold have the walls are closed. Extrusion blow molding can be classified into two major categories: continuous extrusion and intermittent extrusion. Intermittent extrusion is further subdivided into reciprocating screw, ram, and accumulator parison extrusion. Continuous extrusion has the heated parison being continuously extruded. A stationary extruder plasticizes the pushes and the molten plastic through the head to form a continuous parison. A good example of the continuous extrusion process is the wheel machines used by the major companies as Graham, Plastipack, Consolidated Container, Bowl, Seligan, and the other large volume plastics bottles producers. The intermittent parison extrusion blow molding machine using a reciprocating screw is often referred to as short extrusion. The screw rotates and the end retracts, plasticizing or melting as the resin moves back, then charging the short in front of the screws. The screw then rams forward via hydraulic or electric means, pushing, and it pushes the heated plastic through the head and out of the die head, tooling as a parisons. One of the most important items in blow mold design is for the designer to understand the plastic resin and behavior in blow molding the required product. The second one is the extrusion blow molding. The extrusion blow molding is recognizable by the hollow tube that is extruded from the machine to create the parts. This tube is referred to as parisons. A hollow molten then closes. The mold closes and around the parisons and cycles to the blow station. When the blow station, when at the blow station, the parison within the mold is molded through utilizing air pressure, while another parison is being extruded from the machine. This allows for a quicker cycle time. The next one is injection blow molding. The injection blow molding, you can see in the figure, the process of injection blow molding is used for the production of hollow glasses and plastic objects in large quantities. In the IBM process, the polymer is injection molded onto a core pin. Then the core pin is rotated to a blow molding station to be inflated and cooled. This is the largest used of the three blow molding processes and is typically used to make small medical and single serve bottles. The process is divided into three steps: injection, blowing, and ejection. The injection blow molding machine is based on the extruder barrel and screw assembly, which melts the polymer. The molten polymer is fed into a hot runner manifold where It is injected through the nozzles onto a heated cavity and core pin. The cavity mold forms the external shapes is clamped around a core rod, which forms the external shape of the perform. The perform consists of a fully formed bottle or jar neck with a thick tube of polymers attached. There will be it will form by the body similar in appearance to a test tube within a threaded neck. The performance of mold opens. The performance of mold opens and the core rod is rotated and clamped onto the hollow chilled blow mold. The end of the core rod opens and allows compressed air into the perform, which inflates it to the finished article shape. After a cooling period, the blow mold opens and the core rod is rotated to the ejection position. The finished article is stripped off. Okay. The next one is the stretch blow molding. The stretch blow molding is common method for producing soda bottles. The process begins with an injection mold perform. The perform is typically preheated, then stretched in the axial direction and blown into its final shape by a stretched blow molding process. The next one is compression blow molding. The compression blow molding is among the old set materials processing technique. Fundamentally, a compression molding device is a vise-like press that heat, hence it's also known as a heated press. A compression press is rated by its capacity or maximum force. Compression press capacities ranges to 100 tons for smaller parts or parts with a short production run. The larger and more automated machines extended to 5,000 tons, as a minimum, and a 250-ton press is needed to process some reasonable range of the products. This process is suitable for a wide range of individual, industrial, commercial, and consumer parts and products ranging from very small to large automobile body panels, plastic products, areas are lighting and electrical devices, closures, transportation, and appliances, specific items, and electrical valves, switches, switch plates, and receptacles, circuits, breakers, bottle caps, buttons, packagings, containers, covers, protective helmets, pumps, components, gears, brake parts. There are so many examples by which are produced by the compression molding process. The possibilities ranging from the simple geometries to the complex three-dimensional shapes. The rotational molding. The next one, rotational molding, also known as rotomolding or rotocasting, is relatively a smaller part of plastic industry practiced around 2,500 companies around the world, and it consumes approximately 0.7% of the total volume of the world production of plastics. The versatility of rotational molding is constantly demonstrated by a wide range of products in an equally wide range of markets. Ideal nanotank applications for rotational molding are typically complex hollow forms in relatively low quantities. Rotational molding has four basic steps: loading, heating, cooling, and unloading. The main advantages of rotational molding can be summarized as it is ideally suited to manufacture of hollow and complex shapes ranging in size from hearing aid components to industrial tanks of over 20,000 gallons capacity and boats up to 25 feet long. Both molds and machines are simple and relatively low cost. It is a low pressure process that allows thin wall, low strength molds to be used. Small production runs can be cost effective. The next one, that is thermoforming. Thermoforming is a generic term That refers to a process that begins with an extruded sheet of plastic. This process involves the heating the plastic sheet to a temperature range where it is soft or malleable. Thermoforming represents a group of sheet forming process that includes vacuum forming, draft forming, billow, free bubble forming, mechanical bending, matched molding, forming, billet molding, pressure forming, and twin sheet forming. The thermoforming process is usually segmented into thin gauge and thick gauge markets. Thin gauge markets tend towards disposable products such as rigid packaging. Thin gauge or thick gauge markets tend towards permanent or industrial products. Thermoforming is a low temperature, low pressure process in which the sheet is handled a rubbery solid and elastic liquid. Mold are usually single surfaced. The mold materials are relatively inexpensive and are often fabricated in a relatively short times. Thick gauge thermoforming produces a limited number of products and production at a production cost below those produced by other processes such as injection molding. In contrast, the advantages thermoforming has several disadvantages. The incoming material is an extruded sheet with the extrusion process adding 50% or more to the cost of formed product. Thermoforming generates substantially more trim than the other processes that are trim must be ground and re-extruded at additional cost. Thank you.